Good morning. It's Friday morning before spring break, and watching the movie Stand and Deliver has inspired me to get a start on after spring break when we start the unit on exponential functions and logarithmic functions. So if you're on spring break and you're watching these notes because you're inspired and you love to do math, good for you. All right, so let's get right to the math. Rules of exponents. Let's review them. First rule, okay, this part right down here, the A's, this is called the base. Okay, when the bases are the same and you're multiplying, the rule says to add the exponents together. Keep the base the same and add the exponents together. Okay, so just remember, these are rules of exponents. Okay, so these rules only apply to exponents. So, starting off with example problem. 4 times 6 is 24. Okay, here we have x to the third, y squared, x to the fifth, y to the first. So we're multiplying like bases here, x, x. So remember the base stays the same. Add the exponent, so 3 plus 5, 8. Okay, the next base is y. Add the exponents, 2 and 1, make 3. Okay, common error students make is they think that this rule applies to all the numbers, and it doesn't. It doesn't apply to the 4 and the 6. 4 and 6 are coefficients. So 4 times 6, you multiply them like normal. It's only the exponents that get added. Okay? Rule number 2. When you have a base raised to a power, you distribute that power to both bases in the parentheses. Distribute the power to everything in the parentheses. So let's take a look at this example. I'm going to do a prerequisite step here before I give you the answer. I'm going to distribute the 3 to everything in the parentheses. So we're going to have 5 to the third, x to the third, y to the third. Okay? Now we'll get the answer. 5 to the third, that'd be 5 times 5 times 5. 5 times 5 is 25. And multiply by 5 again, we get 125. X to the third, y to the third. Okay? Next rule. Now, when you have a base raised to a power, raised to another power, the rule is when you have a power raised to a power, you multiply them. Okay, so we're going to combine this rule here and this rule here. Notice we have quite a few bases here. So each base gets raised to the third power. So 2 gets raised to the third. Okay, x to the fourth gets raised to the third power. Y gets raised to the third power, and z squared gets raised to the third power. So notice I distributed my power to each one, and now I'm going to apply this rule. So 2 to the third power, that's going to be 2 times 2 times 2, which is 8. Applying the rule, multiply, so 4 times 3 is 12. Applying the rule, well, nothing to apply there. It's just going to be y to the third, and then z to the sixth. All right, let's keep moving along here. Hopefully you're getting the hang of this. Here we have like bases again. This time we're dividing like bases. So the rule is to subtract the exponent. Okay, so let's take a look and see what we get here. Now, we'll talk about this in a moment, but let's just focus on the rule. Subtract exponents. Okay? So first of all, 3 and 12, that's just two numbers that are being divided. Well, 12 does not go into 3 evenly, so we're just going to reduce that. So, you know, we do this without even thinking, but 3/12 we know is 1/4 because 3 goes into 3 once, 3 goes into 12 4 times. But technically, 3 breaks down to 1 times 3, and 12 breaks down to 3 times 4. And so what happens here is, and those are their factors, the threes, they have a common factor of 3, and they get canceled. So we end up with, I think, yeah, we're just going to do a preliminary answer here. 1 on top, 4 on the bottom. Okay, next, our like base is C. So what I'm going to do is I'm going to put the C in the numerator, and we're subtracting, so 5 minus 2 is 3. Okay, D. Now, notice the denominator is 5, the exponent, and the numerator is 1. Okay, so let's just put it in the numerator for now. 1 minus 5 is -4. Okay, and we're going to apply a different rule, which is actually down here shortly. And then our next is E, and 2 minus 2 is 0, which is going to apply another rule, which is right here. Okay, so we end up with 1/4 C to the third. Now D to the -4th. If you want to make an exponent positive, okay, if you want to make an exponent positive, you move it to the other side. So in this case, it's in the numerator, so we move it to the denominator to make it positive. And then e to the 0, anything raised to the 0 power is 1. So e to the 0 power is 1. Now let's clean this up a little bit. Well, do we need the times ones? No. And then we have 4d to the 4th. There are a lot of rules that you have to know for exponents. Okay, so we'll be practicing these quite a bit when we get back from spring break. Okay, moving on. Here we have a division problem and we have an exponent. Just like up here, we distributed the exponent when we had multiplication. Here we distribute the exponent when we have division. So distributing the 3 on the 4, distributing the 3 on the x to the 5th, oops. Okay, and now we have to simplify 4 to the 3rd power. We're going to get 4 times 4 times 4, which is 64. And then applying the previous rule that we just learned, a power to a power is multiply. And there's your answer. Okay, we already talked about this, but any base raised to the 0 power is 1. That's a rule, and I can prove that to you in class if you want to see the proof on that. So what do we have here? We have 5, that stays the same, x squared stays the same, y to the 0 becomes 1. So basically we can just cancel that out because anything times 1 is itself z. Okay, here's another rule that we kind of already talked about. In this case, the base is in the numerator. So to make the exponent positive, you have to put this whole thing in the denominator. And then there needs to be something in the numerator, and we put a 1 there, if need be. If there's nothing else to take this place, you have to put a 1 there. So let's take a look. So remember, all of these numbers, all of these bases, all of these terms are all in the numerator right now, okay? So 4 is in the numerator, stays in the numerator. X to the negative second is in the numerator. We want to never have a negative exponent if possible. So we're going to move it to the denominator. Look at the exponent. Boom. Boom. Becomes positive. Okay? Y to the third. Okay? It's in the numerator. So we drop it down to the denominator. And when the exponent is a 1, we do not need to write it. Okay? We do not need to write it. Now, if it's in the denominator and it's a negative exponent, we just move it to the numerator. Okay? So let's take a look here. We have 5 in the denominator. We have x squared in the numerator. Everything seems to be good so far. Y cubed in the denominator. Everything seems to be fine. And notice we have a negative 4. Now, we could handle this 2 different ways. Okay, we could apply the rule where we subtract, okay, because we have a division. Or we could move this to the numerator. And so we would have x to the 5th times x to the 4th. And then, I said x, didn't I? I'm sorry. Z. Z. So multiplying like bases, we remember. Do you remember? Do you? Do you remember what the rule is when multiplying? Yes. Good job. 5 plus 4, that's right, we add them. We get to the 9th power over 5y cubed. Okay, now let's take a look at this rule. Here we have a fraction raised to the negative n. Notice what happens. If we apply the reciprocal, move a to the denominator, b to the numerator, the exponent becomes positive, and then we distribute it. So let's see, let's apply this. So switch those around. And when we switch it around, what happens to our exponent? It becomes positive. Then distribute it. So 3 squared is 9. Y to the 4th to the 2nd power. Do you remember what to do here? Excellent. Multiply. 2 squared is 4. Notice I'm doing it to every single term. And then x squared. And there's nothing more left to do on that one. That one's as good as it gets. Okay, you're doing a fantastic job. You deserve a break after these video notes. But I got to get going. 1 minute to do one more problem. Next problem. We have a base raised to a fractional exponent. Okay? So, here's what you need to know. This is going to be our power. Always remember the power goes on top. And the number on the bottom is going to be the root. Remember, the roots go in the ground. They go in the hole when you're planting. Okay? So we're going to have, let's see if I can do this now. Running out of time. So we're going to have, first thing I'm going to do is I'm going to put this here inside. Okay? The power is 2. The root is 3. All right. I'm gonna challenge you. See if you can simplify that. And I'll see you on Monday.